Hello, here are the final standard algorithms that you need to know about for hire. So find maximum, find minimum. It's basically one algorithm with a very minor change, obviously. Find maximum, specifically, unlike linear search and counter-occurrences, I guess the idea here really is that we're working with numbers, finding either the largest value or the lowest value. So in terms of the approach to this, again, as I would say with the other algorithms, just have a think. Like if you were given a big list of numbers, asked to find the largest value here, what approach do you take? That's not even a very big list. But what approach do you take to make sure you find it? Imagine there are 10,000 numbers there. How would you go about doing that systematically? It's likely that the approach you take would be the same approach we're going to use for it on a computer. I certainly would work my way through this. I know if there's a small enough set of numbers, you can do it almost glancing at it. But I'd work my way through, okay, 441, that's the highest number so far. Oh no, now that's higher. Okay, and keep going until I find one higher than that. And just work through it systematically. Keep comparing each one to what you've got noted as the highest so far. And if you get all the way through the list, then you should find that you've finally noted the highest number in the list. That is exactly what we do here. Again, lots of similarities between linear search and counter-occurrences and find maximum, minimum. Okay, here's my find maximum. So this is, again, adaptable. It is the same basic kind of idea. If you've got the rough idea for it, it should be easy to adapt. Notice there are loads of similarities between counter-occurrences and find maximum. This is another one that we cannot do as a conditional loop. We have to loop through every single item in the list. I can't say I found the highest number in the list if I haven't been through them all. So I have to do a conditional loop, a for loop through it. I'm going to, inside loop, check a condition and do something if that condition is met. Okay, that's it. The big difference, I guess, is at the start. So usually, except in particular situations, but usually we're going to just note the first thing in the list as the highest number we've got so far. So if I've got a variable called maximum, I'm going to begin as setting that to the first thing in the list. And then I'm going to start looping. This would perhaps be worded a bit better if it said for the rest of the items in the list. So there's no point checking it against itself. So you've set first thing in the list to be the highest, to be maximum. You wouldn't then compare it to itself. You do it from the second item onwards. Which is something the SQA would actually look out for, actually. It would be a little inefficient to compare it to itself again. So, we do something slightly different at the start. There's no getting of targets or anything. There's no particular target. We're just trying to find what the highest number is. Rather than with linear search or counter-occurrences, sometimes we're checking if an item equals a particular thing. Or sometimes it's less than or not equal to or whatever. Specifically, when we're trying to find the maximum value, we want to check if the current item we're looking at is bigger than what we've got noted as the maximum value. And if it is, specifically, we want to say, okay, the maximum value is now that particular item. Okay, you've got to be careful with which way around you get these. So we're checking if what we've got is bigger than what we've got noted as maximum, and if it is, then we assign that new value to maximum, overwrite the old one. Again, we might not need to display stuff, might not be necessary. We can't use a conditional loop, as I mentioned. That's it. Very similar again. Loop, check to see if things are what we're looking for. If they are, do something. Find maximum, find minimum, basically the exact same. I mean, this is a token gesture to show you. Use different variable names. Not that you have to use max and min. It might depend on what you're looking for. But, I mean, it's no different apart from we change the condition. We're looking for things which are lower than the minimum. However, here is a particularly useful algorithm. A slight adaptation of it is finding the position of the highest number in the list. So you might want to, rather than say the highest number is 4,000, you might want to keep track of where that is. So 4,000 is the 13th thing in the list. So to do that, we just add in another variable. So as well as saying the highest number is the first thing in the list, we also at the start are going to say, so the position of the highest number is the first position in the list, 0. Okay, so again, it's still just saying, right, first thing in the list, that's highest at the beginning. We haven't looked at the rest yet, so it's got to be the highest. Then we start looping through. If we find a new highest, then we overwrite things, and we set our position to whatever position we are through the loop. Okay, so as we're looping through the array, as we're traversing the array, we do that. We might need to store the position, we might need to display it, whatever. Display things are always optional. You might also find in that situation, maybe there's more than one time that the highest value appears in the list. And you might have to think about how you could combine that. So for example, you might want to find what the maximum is. So do one pass through the list, finding the maximum, and then you could do a linear search where you're just checking each thing against the maximum. And then you'd find if there's more than one, for example. Anyway, hope that helps. Good luck. See ya.